Okay, so we're going to go over some new material today. Moving on from the ratio and proportion and the variance, and we're going to be looking at some basic geometry today. We're going to start talking about the most basic of geometric shapes. That's that right there. Just a location. It's called a point. And being just a location, it has 0 dimensions. Dimensions are created by movement. If we take that point and I move it in a single direction, if you think of it as like, sliding across the sand and the beach or whatever, it traces out what we call a line segment. Now, in practical application, it's often called a line. Mathematically, a line goes on forever in both directions and never stops. But in practical application, we're only looking at a piece of line. Nothing goes on forever in practicality. So we're looking at a piece of line, the line segment. So we'll often just call that a line. Notice that has moved one direction. That movement in one direction makes it one-dimensional. Now, if I take that line segment that we've created and I drag it again in a second direction, like that, this is where we created those areas that we discussed earlier in the semester. What we're going to be looking at today is taking that point and dragging it, but instead of stopping, we're going to keep going forever in one direction. That's what we call a ray. I can take that same starting point and I can go in a different direction, creating a second ray. And what we create in between them is called an angle. That common starting point is then called a vertex. And the two rays make up the two sides of that angle. The size of an angle is defined to be the difference in direction. Between the two rays. Where that comes from is partly from navigation and navigational directions. Also, if you're looking at trig, if you had some basic trig, that's set up the same way, where you have a 0 degrees direction here, 90 degrees, 180 degrees, 270 degrees, and then back to 360 at 0 degrees again. And those are your navigational directions. So let's say that one ray, of course the vertex of the angle, or the starting point for both rays, is always going to be at that center or origin of the graph. Let's say one ray goes out here at like 19 degrees. The second ray, going back to that vertex, comes up here at, well, let's say that direction is 52 degrees. The difference in direction here is 52 minus 19, or 33 degrees. So that is defined to be a 33-degree angle. It's the difference in their directions. Now, not a lot of people do navigation anymore. This was outdated maybe 100 years ago. So they've kind of altered the definition to come up with an alternative definition for an angle. And what that is based off of is how many degrees are there in a complete turn? 360. So if I just make half a turn and go in the other direction, that is 180 degrees. If I make a quarter of a turn, that's going to be 90 degrees. And I could have similar fractions of a full turn in their related degrees. Now, 90 degrees, we mark it with a box like this, because 90 degrees is a square corner, and that little box is a square in the corner, showing us that is a 90-degree angle. Helps if I actually put it in the corner, but there you go. So let's look at some different angles that can be formed. That 90-degree angle, marked again with that box, that square box, is called a right angle. It is 90 degrees. What do you call an angle that is less than 90 degrees? Acute. You think of someone is called acute thinker. That means they're able to narrow down and look at just the very tiny details, but they don't necessarily see the outlying issues. An angle that is bigger than 90 degrees is called obtuse. Likewise, you can have an obtuse thinker that's capable of seeing the whole picture and all the different possible tangents, but can't focus in on the details very well. Of course, those are bigger than 90 degrees. There are other relationships that we can have with our angles. So let's say we have our angle, and we go back to that vertex, and we have a third ray coming out. What we have created now is technically we have three angles here. We have the first angle, we have the angle between the new ray and the first existing side, and we have the angle between the new ray and that other existing side that was over there. So there's three angles formed. This situation is what we call adjacent angles. And what we're referring to is this one and this one are adjacent. But that third angle has a relationship with them. Because of the way they're set up, they're what we call additive, which means they add up to each other. If I tell you that this angle here was 46 degrees, and this angle here was 32 degrees, the purple angle is 46 degrees plus 32 degrees, or 78 degrees. They can be added together. Likewise, you might be told that this angle here is 41 degrees, and that the total angle here is 124 degrees, and be asked to find this one. How would we do it? Well, if we call that x, we know 41 degrees plus x equals 124. They have to add up. Now we just solve that basic equation by subtracting 41. X equals 83 degrees. Yes, you could have just done 124 minus 41, but I wanted to set it up formally like that for you. So these adjacent angles can have some special relationships. We can have adjacent angles that add up to a straight line. If this angle here is 53 degrees, what's this angle going to have to be? Well, how many degrees are there in a straight line? 180 degrees, right? It's 1/2 turn. So this one here is going to be 180 minus 53, otherwise known as 127 degrees. This situation where two angles add up to a straight line or add up to 180 degrees is what we call supplementary angles. They don't necessarily have to be two adjacent angles like this. Any two angles that add up to 180 are considered to be supplementary. Or we could have two of these angles that add up to a right angle. If we're told that this here is 14 degrees, what's this one here going to be? Well, we know that this angle is how much? 90. So this one has to be 90 minus 14, otherwise known as 76 degrees. Two angles that add up to a right angle or 90 degrees like that are said to be complementary. Or complements. If you're like me, I always had a hard time remembering which one's which. So I remember it by you get complements when you are right. When we have two intersecting lines like this, we have several angle relationships. If I give you this angle here is 36 degrees, I can find all of the other angles here because they're supplements. This, of course, is a straight line here. So that means this angle here has to be supplementary to the 36. how much does it have to be? 180 minus 36 is 144 degrees. But if I want to look at this angle over here, this is a straight line through here. So those two angles have to be supplementary. So this one has to be 180 minus the 144, otherwise known as 36. And of course, this one over here is going to be how much? 144 again, because they're supplementary. Because of this relationship of multiple supplements, these two angles here and here will always be equal. And these two angles here and here will always be equal. That combination of the four angles, the two pairs of equal angles that are formed by intersecting lines, is referred to as vertical angles. Could have just as easily been called horizontal angles, but the two angles that are vertical from each other are equal. The two angles that are horizontal from each other are also equal. They're also called vertical angles even though they're on the horizontal. So now with that relationship in place, two lines that go like this. Now you might have heard them defined as lines that never intersect. They're called what? Parallel. Two lines that intersect at a right angle are called, everybody know? Perpendicular. Perpendicular means more than just at a right angle. It means it's a right angle at every possible measurable direction. For two lines, it means just the intersected right angle. But you could have a line and a surface. Like if I have my pen sticking out of the surface, or put a stick out of the surface of the board. Like this. No matter what direction I measure that angle in, it's going to be a right angle. That's perpendicular. A right angle in every direction. Parallel, we're used to saying parallel lines just are lines that don't intersect, which on a flat piece of paper like the screen here is fine. But if we're out in space, let's say we have this line and this line. Are they parallel? No, they'll never. Will they ever intersect? No. So in 3 dimensions, saying that the lines will never intersect is not adequate. Parallel is actually, the technical definition is everywhere equidistant. In other words, always the same distance apart. Two parallel lines are always the same distance apart. If I cut those parallel lines with another line, it's called a transversal. Transversal doesn't even have to cut parallel lines. It's any line that cuts across two or more other lines. If I give you one angle here, say I tell you that this angle here is 61 degrees. We have that vertical angle situation right here. What's this angle have to be? Right here. 180 minus 61 or 118, right? What's this one have to be? Not everybody at once. Has to be 61. And this one? 119 again. How about down here? Well, if this line here were moved, or to pull it down here, you can see it'll set perfectly on the other one because they're parallel. What's this angle here then have to be? Well, it's just the same as this one, 61 degrees. Of course, the other ones then have to follow suit. 119, 61, 118. Now, there are a lot of rules out there for governing the angles when a transversal crosses parallel lines. You got opposite interior and corresponding interior, corresponding exterior, alternate exterior, all sorts of wonderful combinations that they talk about. We're not really worried about all that vocabulary and naming all those angles. All we need to know is when two parallel lines are cut by a transversal, all 8 of the angles formed are either equal or supplementary. If they're not equal to each other, they're supplementary to each other. So if you know one of them, you know all 8 of them. The final angle relationship we want to talk about today is a triangle. The angles in a triangle always add up to the same number. Does anybody know what it is? Oh, 180. Yeah. The reason for that is this. Let's say I'm moving in this direction and I turn to go down this side, right? So I'm going down this side, and here I turn so I can go down this side. And I turn back here. How far have I turned between these 3 angles here? I'll call this angle A, B, and C. I made a complete turn. I've turned 360 degrees, haven't I? What I have here, if I call this angles D, E, and F. These 2 angles have to add up to how much? It's a straight line, right? 180. What do these 2 angles have to add up to? 180. What do these 2 have to add up to? 180, right? So all of those have to add up to 180 plus 180 plus 180 is 540 degrees. Well, if I take out these 3 angles, A, B, and C, I've reduced it by 360 degrees. So D plus E plus F has to add up to 180 degrees. Those are my interior angles. So the 3 angles on the interior of a triangle always add up to 180 degrees. So, let's say that I give you that this angle here is 32 degrees, and this angle here is 85 degrees. I want to know this angle, and that angle. How can I possibly do that? Well, this is 32. What's this one have to be? 32. This one here would have to be 148. What's this angle here have to be? Well, that's a straight line, right? So 180 minus 85 is 95 degrees. So now how do I find this one? I know those 2, if I call that x, I know x plus 32 plus 95 has to add up to 180. So I combine the 32 and the 95, that's 127, as if 180. Subtract the 127, x equals 52 degrees. So that means this is 53, and C has to be 180 minus 53, or 127 degrees. So we got C. How about B down here? What's this angle have to be? 32 degrees. So B has to be 180 minus 32, or 148 degrees. How about A over here? 53. Same as this one up here. So we can find, with those rules, if we have just a few angles in a situation, we can find several others. In your book, page 403, exercise 12.1. Problems 1 through 35, the odd.